So from yesterday, we are starting a new initiative that we will be posting 3 questions from the lead code, one from the easy, one medium, and one hard. And we will be doing this session regularly on this time only. So there were 3 questions. I will share my screen. Yeah, I hope it is visible to you all. Yeah, the first question was the license key formatting. And this question basically had a string, and this string, along with this string, we had a integer value. And what we have to do is just cluster the group, cluster the string in the, we have given an integer 4, so we have to cluster from the backward, like 4 from the backward, and then again 4. And we can leave the first group with the characters less than 4 and equal to 4 as well. So for this example, we can see that we have a string, and this string has some alphanumeric characters as well as a dash. So what we have to do is basically only alphanumerical characters we have to concatenate with a group of 4, and uh, uh, to distinguish between these two groups, we'll add a dash sign in between. So this was the problem statement. And uh, one more thing in this is the first group should have less than the value of k. The characters should be of less than or equal to the value of k. So I hope the question might be clear to you all. Is there any question regarding?
Hello.
Yeah.
Hey, so the question is pretty clear to me. One thing I have is when we look at, are we allowed to like modify the original string when we are as a part of, the approach?
As I think it's not mentioned over here, like we can.
Right.
Yeah.
So we are right. Like we just
Yeah.
take that. We can make
Yeah.
change.
Yeah.
Okay.
So anybody else? Do you have any questions? Anyone?
Hi, Ashish. So my question is that is string libraries allowed to be used here?
Yeah, obviously we can use the string library.
Okay, thanks.
Anybody tried to solve this question? Like, if
Yes,
anyone can please tell his or her approach, then we can move forward.
yes, I have solved the question.
Yeah. So please go ahead.
How should I describe my solution? Should I paste the code here or
Okay. Okay. Can you share your screen? I will stop sharing mine.
yeah?
Yeah. Sure.
So is my screen visible?
Yeah. Yeah.
Yeah. So the solution I tried is that I first erased all the occurrences of the dashes from
Yeah.
the original string, and then I iterated the string backwards, and also while iterating I kept a count of the of the k using a temporary variable temp, as you can see here. And while iterating I kept on pushing back the characters, each characters from the string in reverse fashion. And also as soon as the temp arrives at a zero, that is arrives at a zero, so I just pushed a dash, and then I reversed the result, and so that arrives to my solution.
Okay. Fine. So anybody else with any different approach?
Hello?
Yeah.
Hello?
Yeah.
Yeah, can
Please
you hear
go
me?
ahead.
Okay, yeah. So I see one question Jasveer also asked on my previous one. So my approach was very similar to what was explained, except that I didn't use stack explicitly. Um, the idea was the same, that I'm trying to start from the end of the string and trying to process it. But I just use like a string builder class. Um, and yeah, so
Okay.
does that make sense? Or like, I don't know, like if I need to, if any other questions or details.
Okay. So I will tell what I did basically. No. So I wrote a pretty lengthy code for this. So for the first, I started removing the dashes, and I just checked whether the character is a alphanumeric character or not, and then I pushed back into a temporary string, and then I just iterated the string from the backward, and up till the k, I just added it in a new string, and then I pushed it into a stack. Then again, I iterated over the stack, and then I popped the top element and then concatenated with the dash, and I I get a success from that. So can we move forward, or do we have any other approaches?
Hey,
Yeah,
do you
sorry.
even sorry, can you hear me?
Yeah.
Yeah, do you even need to traverse string twice? I mean, you could have just done like removing the dashes and adding it to the stack in the same traversal, and
Yeah.
then-
I could have done that.
yeah, it doesn't make a difference to the complexity, but I think, I mean,
Yeah. It doesn't make the, but just for my simplicity, I do that.
okay.
Yeah.
I also followed a similar approach. The only difference was, instead of putting it into a stack or something, what I did was I iterated the string from the end
Right.
and kept a pointer. And
Okay.
as soon as I was going and I found a dash or a character, I inserted the character with the last pointer available. Dashes I ignored, and once I was up to the string k, I inserted a dash manually and then moved on. So at the end, you will have all the formatted string at the end, and you will have some characters left at the start. So that you can ignore and create a new string builder out of it at the end.
Yeah, I got it.
Yeah, that's exactly how I approached it. Right.
Yeah. So shall we move forward to the next question?
One quick question on
Yeah.
this. Like we see, right, the approach is pretty similar whether we use stack or, like a string builder class.
Yeah.
Uh, do we see any, uh, is there some thoughts on like one versus other in terms of data structure? I guess the memory requirements are pretty much the same, right? We are pushing onto the stack. Similarly, I'm creating a string builder object. So it seems to me pretty similar. I mean, almost the same, but I don't know if
Yeah, I
anyone
guess
has
the
any
space
thoughts on that.
complexity will be the same. I don't think the space complexity will like differ in both cases.
I think you'll anyway have to use a string builder, right? Even if you use a stack, when you're popping elements out of the stack, if you're adding it to the string one by one, it's actually creating a new string.
Oh, right. Yeah,
So I
never
think
mind.
string builder would have to be used in any case.
And also, like Vivek also mentioned, right? So, yeah, I got confused with stack. I think we would also have to, it's taking extra space, right?
Correct. So I think the only thing that we are achieving with stack is reversal, which we could have done without a stack too.
Right.
Yeah.
Yeah, right.
But
Okay.
in any case, we'll need extra space, to return the result actually, because the
Correct.
strings are immutable usually. So if you create a new string, you will definitely need extra space.
No, that's true. But if we use stack, we are pushing all those, elements in stack, and then to output the result, we are creating isn't it that
Okay, so okay,
creating
okay, got it, got it. So we are talking about the intermediate space, so not
yeah,
the complexity, space
yeah,
complexity.
yeah, right.
Do you have any more questions? Or
I think we can move to the next one.
okay. So the second question was like find a right interval. This question was basically from the tag binary search. So it's it does says like if we have some 2D vector or a 2D array, you can say, and we just have to check whether the ith array or ith vector, uh, in the ith vector, the last value should be greater than or equal to the if we are checking for this 3 comma 4, then we have to check whether this 4 uh, is greater than or equal to this, um, or this, like, so if it doesn't have any such arrays, then we will return -1. For this case 2 comma 3, we can see that this the last value of this array has equal to the array at the 0th index, so we have to return 0. And in this case 1 comma 2, we are saying that the last value 2 and the array at the index even 2 comma 3, the lower bound is all is 2. So basically we have to return the index of the vector, so it's 1. I guess it's pretty much simple to understand. So do you have any questions regarding the problem?
What about duplicates? We are not allowed.
So it is already mentioned over that here that we have to assume that no
Okay,
intervals
okay.
have same starting point.
Yeah, yeah. Thanks. Sorry.
I have not coded this one, but I do have an approach for this. So what I did was, so I first started with how I can have this ordered first. So what I did was sort them out, sort the numbers in the order of their first numbers. Like in this case, it will be 1, 2, 2, 3, and then 3, 4. And then take each element and then do a binary search on the entire array, except for the element which is being considered based on the second element in the current element. Like if I am searching for the element which is after the 3, I'll take the 2 3 pair. I'll take for the binary search of 3 and try to find the seal of that in the array. If I am able to find that, that's the index which I will take up. So during the course of this, what I figured out was we are doing the similar kind of activity twice. Like once we are sorting the elements and then doing the same activity, taking each element and then finding the corresponding seal. So what I did was came up with a modified merge sort kind of approach, where instead of just sorting the elements, I found the index which is the next one. So if there's already an index assigned to a position, I check whether the element which is being considered is already greater than or smaller than the end.
Okay, shall I go with my approach, what I did?
Sure.
I have one question. If I understood right, why are we sorting the? I understand the sorting part of the the start elements, like because we have to compare the end point of the one of the intervals. But why did you mention that we are also sorting in the beginning each interval, like we are putting them as 1 2 2 3 and 3 4, like something like that?
I guess not. We just have to see the last value, and
Correct.
we have to just see the last and the first value. So we can create two different vectors, or we can create two different
Right, right.
arrays,
Okay.
and
Then
then we
maybe
can
I,
sort just the first one.
sure, sure. Okay.
Yeah.
Never mind. Sorry about that.
So what I did is I just iterated over the 2D vector, and then I just pushed all the elements in the front, like 3, 2, and 1, and created it as a first. Then I created one more pair which had two data types integer, and I made a pair of the intervals like the last intervals 4, 3, and 2, and their indexes as well because I need those indexes afterwards. So I sorted the vector, the pair of vectors, and then I looked the lower bound. Like if we need the lower bound of 2, then we will be easily getting it with the help of the C++ SQL. It's basically a binary search we are doing, and I just used a iterator pointer and then just pushed into a new answer vector, and then I returned it.
Yeah, that's exactly the thing which I did first, but then I modified it to a modified merge sort. I'll
Okay.
post the solution on
Yeah, please.
the Slack.
Okay. So, are there any other approaches? Anyone?
Can you just explain the part once again? Like I understand until where you are sorting the vectors.
Okay, so from here, like
Yes.
yeah, so in the vector pair, it has the first first data like the 3, 2, 1, and I I made this pair with the with its indexes like 3 comma 0, then 2 comma 1, then 1 comma 2. So I sorted the pair of vectors depending upon the what was the value of the uh, first array. So after getting the sorted vector, I iterated through this vector, and then I found the lower bound of the first of I, like what was my first of I. And for this, since I had a pair of vectors, so I did a -1 in the second part, and I got the index value. And if the index value was equal to the first dot size, then I pushed back -1. Else, I just put check the string, check the second part of the pair.
Okay. Okay, makes sense. I was a little confused with the lower bound function. I think it's specific to C++, but
Yeah, it's C++ STL, I guess. So
sure, it makes sense. Thank you.
it's simply a I would say a binary search, a modified binary search, in which we will be getting a value which is either equal to or greater than the target value.
Okay, makes
Yeah.
sense.
Yeah, let's say if you are searching for 2 in a array, then if 2 is not present, then we'll be getting 3 or 4, just greater than 2. Or if we have 2, then we'll be returning 2.
Got it. Thanks.
Yeah. Anybody else? Okay. So shall we move to the last question?
Yeah, Ashish, do you want to discuss the time and space complexity of your solution?
Okay. So the time and space complexity will be just n into m. It's not more than that. The n will be the number of rows and m will be the number of columns.
You're actually sorting also.
Yeah.
Yeah. So yeah, n into m, and then it's n log n. Okay.
So it should be n log m.
Okay, let me see.
Yes, even I feel it should be n log m because the sorting is the n is the length of the array and m is how many elements, how many intervals I mean present.
Yeah, it should be am into log m. Either am into log m or an into log m. Okay. Shall we move forward? Okay.
Yeah.
So this was the last problem then, the race car, and this problem states whether we have to find the position. Uh, uh, Basically, we are given with the position, and we have to find the sequence, the minimum sequence that we need of instructions. So there are two instructions. There is one instruction A for accelerate and R for reverse. So whenever we are giving an instruction A, then it does mean the position will be increased by the speed, and speed will be equal to speed into 2. The speed will get multiplied twice. So and if the instruction is R, then speed will become -1 if the speed is positive. Otherwise, speed will become 1, and our position will remain the same. It won't change. So we will be given a target value. Let's say the target is 3. So it does mean we have to reach to the position 3. And to reach the position 3, what will be the shortest sequence required? Like to reach position 3, the shortest sequence required is AA. So initially we will start from the position 0 and our speed will be 1. So we'll reach to the position 1. Then after reaching to the position 1, our speed will be 1 into 2. That's 2. So again, we will add back with the position and we will reach to the position number 3. So ultimately, we have to find out the shortest sequence, and the shortest sequence in such way that we reach to the target position. Is the question clear?
Yeah.
Yes, it's clear.
So as I see the constant values, I can guess, yeah, it's a question from the dynamic programming. I haven't solved it. Anyone else with any approach?
I tried it, but it's failing for a couple of scenarios. So what I did was, just took few samples like continuous AAs, and then found out like all the numbers are in the form of 2 raised to power I minus 1. And what I did was just took a number, like let's suppose 156, or suppose let's say 128. Then I tried to find the nearest number in the form of 2 raised to power I minus 1. So let's say for 128, it becomes 127 plus 1. So there are two ways we can reach 128. Either it is 127 plus 1 or 255 minus, I think it's 97 or something. Then I tried to, so 127 can directly be reached from the A steps or the 2 raised to power I minus 1 I steps. And then recursively try to call what is the minimum number of steps that I can reach, that I can use to find 1, which is the remaining part. It is working for some scenarios, but for a scenario like 5, it's not working. So seems like I am not able to find the correct sequence right now, but seems like there's some other logic that we have to see.
I don't know if my logic will work or not, but it's a simple subsequence question. Like we can use the subsequence method, as in for every call, every position, I'll make 2 calls. One will be for A and one will be for R. And from both the calls, I'll say that give me the minimum length of the string and I'll output it. So directly I'll get the answer. Like I don't think that we're even required to use deep. It won't give any TLE error.
Can you please say once again? Because
Okay, let's start for the first example. I'm at 0. So from the 0th call, I'll say that you either go with the A part or go with the reverse part. Okay. So at the A part, as you can see, my speed will be 2, and it will get multiplied. My position will increase, and my speed will get multiplied by 2. Then from the second call, I'll again make 2 calls, one for A and one for R, and I'll
Yeah,
see that if I'm equal to like my target position, then I'll return that path. I'll make a class wherein I'll store the size and my target position. That's all.
yeah, I got it. Yeah.
So that solution I think will be 2 is to power n, right? Or yeah, 2 is to power n.
Yeah.
Okay.
And the constraints, yeah. So I guess we will be getting a tail. We might be getting a tail for this because
Yes, I think Tanmay's solution would work, but just that it's not optimum solution because we are exploring all the possibilities, which would
yeah.
be, yeah, so which might give a TLE here.
Any other approach like DFS, BFS, it might work, I guess.
It's like similar to DFS, BFS both. It's just the opposite way out. I'm starting from 0 in DFS will start from 3 and start exploring the reverse thing. I
Okay.
guess there'll be some DP condition that could be applied.
Anybody solve this? Try to solve this.
No, she's not from my side.
Okay. So I think the the possibilities, like if we get a then R, then again for the next iteration we will check for A and R. I think that will work, but I'm not sure about the time complexity of that. Okay. Yes.
Anyone else has any? Sorry.
Hello.
Yes. Yes.
I tried solving this question using BFS. It is similar to Tanmay's approach, but I think Tanmay's is a recursion-based approach. It's a DFS-based approach where you actually go, you follow a particular path and it leads and see where it leads you to. But BFS is more restrictive in that sense. So as Tanmay said, like we begin from our source, and then we have two options. We can do either accelerate or we can do the R option that for the decelerate. And then for counting the number of BFS grows in the form of a layered mode, right? Like first you have one vertex and then you'll have two vertex that belong to the second layer. Then subsequently four nodes that would be discovered in the third move. So I use generally for these questions I use two queues, like the where one queue contains the vertices which are being of one layer and the other queue contains the vertices of other layer. This approach generally works, but I'm getting TLE, so I'm trying to optimize the data. I was using pair to identify the combination of position and the speed. So I'm trying to use a string something like that. I think at the discussion forum and to have used the same approach. So I'll post it in the group if I get unexpected. Post my code.
Okay. So you try with your pair approach, and then you you can post your code in the channel.
Yeah, sure.
Yeah. So, do you have any other questions or approaches, or shall we end the session?
Actually, this is Vivek. I have a few quick ones to kind of add on top of this. Right. So one is, would the question be any different if you start from the beginning or the end? Like, would you change your approach significantly if you started from the destination and then you're working backwards towards the origin? That is open for everyone.
Vivek, I didn't get you. What do you mean by like origin, destination, all this?
You have to reach a target location, right? That's the goal here.
Right.
And your starting point
Right.
is position 0.
Mm-hmm.
And you can start your computation from position 0 and essentially say that if I do accelerate, and then reverse, then I get the answer. Or can you do it from the end? In this case, I want to hear what people are thinking. But generally, for such traversal and exploring problem, there's always worth looking whether you can actually start from the end as well. Here you cannot,
Yeah, Vivek.
because
Mm-hmm.
why can't you start from the end here? Because you wouldn't know what the velocity is at that time, right? You don't know the speed at that point.
Yeah.
So this is only forward looking, but typically in a maze question, even reverse actually works. Like when you're actually solving a maze, as a kid, when we had all these maze questions, right, where you have a starting point and ending point. If you actually start from the end and try to solve the maze, it's much faster.
I guess I got the DP approach. I don't know if it's DP approach or not. I just used basic mathematics, and I don't know. Well, I'm not sure that if it'll work, but I guess it should work. Basically, if we just go on with the A's, it's gonna become a AGP series, okay? Arithmetic geometric progression series. So we have the expression for it. We already know the expression for it. And for in case I'm having all the numbers, like as in I'll be having 0, 1, 3. Is it still working? Okay.
Yeah, he just turned on the screen share. You can share your screen if you want.
I won't be able to write. That's fine. I'm saying that I'll be having numbers like 0, 1, 3, 7, 13, 21. It's a arithmetic geometric progression series. Okay. So I directly know that what will be the positions from wherein I'll have to reverse. I know the speeds. A speed is just a geometric progression, and the position is following an AGP series. So for in case the question was like I had a position. I guess it was I had a target of 6. So I knew at fourth position, at the fourth interval, that fourth accelerating part, my position will be 7. And I'll have to reverse from there only. So basically, you can directly reach the nearest target position and then use the reversing conditions to get the answer. It will be like making our approach, making our solution in order of 1 or so.
But that's not, no,
Yeah.
that's good. Log n of sorts, right? Because you're doubling the speed every time. So it's not order of 1, but it's log n. Like to compute the series, you will have to do a log n, right?
No. How come it's log n? It's just a basic mathematics calculation of multiplication division, right?
But that's
So Tanmay, that
okay,
will work if you have a number in the form of 2 to the power I minus 1. But what about a number which is not exactly in that form? Like let's take an example of 5.
Yeah, that's what I said. In this series, I'm having numbers such as 3 and 7.
Right.
So I'll go on with my series. Okay, yeah, it's log n. I'll go on with my series and I'll look the nearest number to 5. It's either 3, but matlab, at the point wherein I'll get a number greater than 5, I'll start adding r's to my answer and I'll get the answer if it's reachable.
No, but hang on one second, right? The reverse is like once you reverse, you can also further accelerate in the back, right?
Yeah.
So in some scenarios, you don't have to. You could either overshoot. Let's assume that the way it is that you're actually overshooting it, significant or just subtly. Then what will happen is that let's assume that you reach 1000 and 1001 was the answer. So because of the acceleration, you'll probably go all the way to 2000. And now you're backtracking from 2000 using reverse and accelerates, right? Instead, it'll probably be a better idea to go from 1000 to like 999 and then go forward. So you don't, your answer is always not to overshoot and come back, but you may also undershoot and then do a quick reverse and then accelerate, right? Does that make sense? Like both are reasonable answers, and it's also possible that you may actually have a better answer by doing it by actually resetting yourself at 200 instead of 1000 when the actual answer is 1001.
Does Tanmay solution give us the minimum sequence? Because I think the result asked was a minimum sequence that should be the
Correct.
answer.
And that minimum sequence may actually happen with a different equation. Like what you're doing is a greedy approach.
Yes, that's what I also feel.
Yeah, and that's probably not the may or may not actually work.
What I'm thinking of doing is, for in case I'm having 1000, I'll reach two numbers. One is lesser than 1000 and one is more than 1000.
Correct.
So
the more than 1000 makes sense. The more than 1000, you're just doing a reverse and then you're just trying to get there, right? That makes sense.
I'll just try and approach it. Like I'm having two approaches in my mind right now. One is that for two numbers, for in case I got 1001 and I got 999, I'll start my subsequence from there.
Mm-hmm.
And the other thing that I'm thinking is that I told you that I'll overshoot from 1000 and I'll go backwards. I'll try it and let you know. I just came back home right now, so I didn't get the time to try these questions.
Got it. So how about, I think we talked about dynamic programming earlier. The only thing that I was trying to understand was like, I don't know if I heard that in the conversation discussion was once you are on the reverse direction, you can actually remap the entire question, right? So if you, for whatever the example we talked about, if you overshoot to 1000 and go to 2000, for example, and then at that point, if you hit the reverse, you're actually essentially starting in the reverse. Right, which means that now you need to go 999 distance at a speed of 1, and your position is essentially like you can reverse or remap your origin to that 2000 point becomes your new 0, and your velocity becomes like +1 instead of -1, even though it's like towards the left, and the destination is 999 instead of 1001 because you're doing a remapping exercise. And then you can just use whatever solution that you had before for this one.
So is that like a top-down solution?
No, it is not a top-down solution. It will be it is still like a bottom-up solution. You're still starting from the starting point and then you're going ahead. Essentially the way it is working is that you need to create like a memoized array of what is the fastest way to reach point X. That's it. Okay.
Okay, so
it's a two-dimensional thing, right?
Sorry.
It's a two-dimensional array of what is the fastest way to reach point X with speed Y, essentially, which is what the memoization technique that you talked about. The only thing that I was saying was that you can also remap the reverse algorithm in such a way that it actually works backwards, works for you.
Yes, got it. So we are like imagining the problem from the opposite end, but it's still the bottom-up approach. Yeah, got it.
That is correct. There is one thing that I wanted to actually highlight in this one was that I didn't think I heard the discussion on this one. Is that one of the concerns that I have, especially with the Tanmay's approach, is that what if I actually give you a number? I mean, I know the constraints are actually much smaller here. What if I increase the constraints to as close to the integer max as possible? Right. So then in that case, you may have a real legal solution or a valid solution that is there, which might even be better and faster and quicker. But when you do speed equal to speed times 2, right, you may actually overflow the integer maximum. In like 31 steps, you will actually overflow the maximum, right? So we may have to consider integer max, integer out of bounds, especially when you're actually trying to multiply numbers. Like especially if you're you constantly keep multiplying or you keep adding, you need to keep that in account. So just remember that. That make sense?
Doesn't that make sense? Could you please approach the repeat the DP approach that you told just right now?
Sure. So let's do the DP approach first. So the DP approach is essentially what we're trying to do is we're trying to, for all possible solutions that you have, essentially what we're saying is that given point 0, right? What is the, how, in how many steps can you reach there? That's essentially point 0 with speed 1. How many, what's the minimum steps to get there? It's just 0, right? You do nothing, you're there already. Correct?
Yeah.
Okay. What is the point of getting, like, how do you get to point 1 with step 1 or with speed 1?
Simple A.
Just accelerate once, because then the position becomes position plus 1, and then the speed becomes 2 at that point of time, right? And what is the thing of getting to point 3 with speed 4? That is also like 2 A's and so on, right?
Okay.
And then you can keep, if you do that, what you're building your DP table is essentially in one axis it is the positions, in the other axis it is the speed.
Okay.
Got it? Now
Got it.
the thing is that on the reverse, right? If you're trying to reverse the equation, you can actually copy from the DP itself. Like if your speed is -1 and your current position is say 100, right? Then you can do a remapping exercise of what the origin looks like and what the direction of the speed is. So you can, your DP table will never contain negative speeds.
Yeah, I got it. Somewhat got it.
Like you'll never have negative speeds in your DP table,
Yeah, that's true.
right? Because
Okay.
the equation is reasonably symmetric at that point of time, right? So you can do that. So that's the only thing there, and then keep computing till you essentially reach the target. And you don't really care about which speed that you are at that point of time, right? You don't have to be at a specific speed to the target.
Okay, got it.
Vivek, I have just one doubt. The approach that I tried, I'll just share my screen. I'm just not able to understand where it's wrong or what's wrong with that. Why it is not able to give the solution.
Go for it.
What I did was, just let's take a number of 156. So we can reach 156 in two forms, two ways if I consider the sequence of form 2 raised to power I minus 1. So like 127 plus 29 or 255 minus 99. And then what I did was this number can be directly, got in I steps, which is IAs. And then, this one I again broke down into the next steps, like it can be given from 31 minus 2 or 15.4. Kind of, creating that memorization table. Like if I reach 29 in suppose 4 steps or 5 steps, so I can reuse it if I get it somewhere else. But, it works for a couple of numbers, but for a few numbers it's not working. Like for 5, it's not giving the correct answer. For me, it's coming around 9, whereas the answer is around 8.
And why do you think that is? I mean, I think I know the answer why, but why do you think that is?
I believe I'm not taking into consideration the speed part. I think that's the, but I'm not able to figure out where I would put that.
I don't think it's the speed, right? The speed is reset to 1 or -1 because of the reverse. So that's not the problem. The challenge that you have is that you may actually have, again, as I said, right? In this particular case, can you write the AGP?
Yeah.
It starts with 1, then 3. Oh, 0, 1, 3. That's the speed, right? Fantastic. So now the problem that you have here is that what makes you certain that you have to do a 127 or 127 and forwards or 255 and backwards? Why would you not do a 63, a quick reverse, and then jump forwards? Like do 2 quick reverses after 63 and then jump forwards. or like 31 and do a reverse and then two reverses.
Oh, you're saying resetting the speed at 63 instead of 127.
Exactly, right?
Oh, yeah.
And that's what you're missing here.
Got it.
Okay, which is why the DP approach is a little crappy here, but BFS is probably the easiest because at any point of time, the decision making for you is either you can do an accelerate or you can do a reverse. So you can just do a BFS on that one and then keep going, right? That's the fastest way of actually solving this, quickest way of solving this. DP works, but you just have to think about how to structure that. It's a little
Yeah,
harder.
and that still will be at among these points only, right?
For which one?
For taking a reverse action and then moving forward, it will be one of those.
Yeah, but it resets the equation completely, right? Let's assume you don't have to do two reverses.
It will reset the equation. I'm just trying to figure out how many steps or how many branches it will take, like BFS. So which will essentially.
But you could do a reverse, accelerate, and then a reverse. And that's probably still better, because what might happen is that, as you're resetting, you don't have to reset it only to -1, +1. You could reset or you could reverse and you could go back a little. So you could go from 63. If you do a reverse, you're going to 62, right? No, you just stay at the same place as a -1 value.
No, if I do one reverse, if I accelerate after that, I'll go in the backward direction.
Correct. But you may actually go twice or thrice in the backward direction because that might give you more bang for the buck. Right?
So this is interesting. Hi, this is Bhavesh. So Vivek, what you said, that is interesting. So if we do BFS, then can we apply the shortest path algorithm?
Yeah, that's it. So at any point of time, you can only point of time you can do A or R. That's it. That's
exactly. So
right?
So from I'll start with initial position. I'll do A and R, and then basically keep expanding it. If I'm going beyond the desired result, then probably I will.
No, you can't stop. You have to still continue. It's just BFS. So if you find a solution that is actually it is possible, like given his example, right? 255 minus 99. So you may overshoot and then do a reverse and come back from the reverse direction. You can do that too.
I see, but DFS or BFS? I was thinking BFS.
Breadth first search, yes. It has to be breadth.
Okay. All right. Okay.
So that's all. Like the simplest solution for this one would be a BFS because because the question says that find the shortest command for the race car, right? So that's the easiest answer. But if you want to do a dynamic programming, it kind of works, but the question has a bunch of different nuances that actually makes it harder. The only additional thing I wanted to tell people, which I think I mentioned it, but I don't think we caught on to it as much, was this question may not need it, but you actually have problems with integer overflow if there are concerns. So let me ask you slightly different questions and see if we have about 10 minutes, right? So let's actually, any other questions on this question alone? Going once, going twice. All right. So how many of you are familiar with Collatz Conjecture?
Can you please repeat? Familiar with?
Collatz Conjecture. I've mentioned that in the chat. If you the name.
Okay.
Yes, no, maybe. You can look at it in Wikipedia if you want. Collatz Conjecture is actually a pretty straightforward conjecture where what it says is that given a number in sequence, you start with any number. If the number is even, then you just divide it by 2, right? So if like f of 16, the next value essentially is 8, and then after 8 it is 4. After 4 it is 2. After 2 it is 1. If the number is odd, which is like 1, then essentially you replace it with 3n plus 1. Okay, that's it. So it's either n by 2 if even, and it's 3n plus 1 if odd. Okay, so for every time the number is even, it actually reduces, and 3n plus 1 will make it like even, right? If an odd number, 3 times an odd number plus 1 will be an even number. So again, it will go down, and then that may be an odd number, and then it may go up and things like that. So the Collatz conjecture is that any natural number will actually reduce to 0 or reduce to 1, and always. So if I think if you look at the example in Wikipedia, it actually gives you the example. Let me just paste one of the examples here. Is that if you have sequence like n starts with 12, then since it's 12, 12 by 2 is 6. Since it's 6, 6 by 2 is 3. Since it's 3, it's actually 3 times 3 is 9. 9 plus 1 is 10. So it's 10. And then 10 becomes 5. 5 becomes 15 plus 1 is 16. 16 becomes 16, 8, 4, 2, 1. And then 1 again becomes 4. And it will actually be flipping between 1 and 4 after that. Right? 1, 4, 2, 1, 1, 4, 2, 1, 1, 4, 2, 1. Right? It will keep going through that loop. So the question was that, like, how would you test this Collatz conjecture out? And can you prove that for all, like say integer, 32-bit integers, Collatz conjecture is actually holding true? What do you guys think? When I saw the race car problem, it kind of triggered this Collatz conjecture bit for me. Any thoughts? Folks are quiet.
Actually performing that sequence like based on the equation like n by 2, 3 n minus 1 till it becomes 1, but I don't know if it may be a very long sequence.
It will be depending on the number. Like I've given you one example, which is 12. I can give another example, which is this one. And you can actually, if you just search for like Collatz JavaScript or something like that, there'll be somebody who must have written a program.
I have a doubt. What do we mean by proving it for 32-bit integers? Proving that Collatz conjecture is true.
So the question that the Collatz conjecture is that given any natural number, it will always reduce to 1. The sequence will always end at, it will become 1. So tell me, like essentially tell me if it's true. Tell me for like, how will you compute the Collatz sequence or for every number and make sure that every natural number like 1 to 2 power 31 minus 1, all of them actually reduce to a smaller number. Yeah, reduce to 1 basically.
Would it be like starting from the smaller number and adding to like memorize the result? So basically, whenever you are at a bigger number, you divide it by 2 and see if that already exists in your memorization.
Can you say that one more time? Sorry, my audio just cut off.
So I want to say that would it be like something like starting from the smallest number and then memorizing the result? So basically, since we know that 1 does follow it, right? So just memorizing the result, 2 follows it, 4 follows it. So whenever we go to a bigger number, like when I'm at 8, if I just divide it by 2 and see what my result is, if it already exists in my memorization, then I'm good with it.
But you realize that how much memory you need, right? You need 2 power 31.
That is true.
And that's not really tenable.
But but Vivek, we want to find out if the all 32-bit integer are covered or not, right?
That's all you want to find out, correct?
I see. So
basically, hey, can you go on mute? We're getting feedback from you.
So basically, we can, start from any number and we might overshoot and then come back in the range, right, to reach 1. For example, I'm at integer max and I might have to double and then
That is correct. That is correct. That is
So,
the problem. So there is no guarantee that that even like one of the simplest hacks that people explained was saying, why don't I use long as my Collatz sequence keeper, and then I will actually just use that. But there is no guarantee that that all integers are resolvable in the long space.
I think if we could use something similar to sieve of Erasmus, like we'll go from
C
one
C
sieve of
won't work, right?
Erasmus.
No, C won't work in this. That's a good concept. So the way you want to, so a couple of things, right? So fantastic point. So I think what just like how Jaspir mentioned, one thing you can do is you can create what is called like a high water mark, and the idea is that you create a line that says like all numbers below this converge to 0 or converge to 1. I know that, right? And every number below k or below x actually converges. You know that. So then what you can do is for x plus 1, you keep doing whatever you are trying to do, and then when it actually it falls below x, right? You know that that is now resolved.
Yeah.
So you, and then you go to x plus 2, because now the high water mark is moved to x plus 1. So then you look at x plus 2. As long as x plus 2's sequence falls below x plus 1, you are good. But the problem with this is that it actually goes, when it goes high, it can go super far out in the future. So there is no guarantee that it'll actually for sure it'll overflow the integer space, because a number which is an odd number which is maxent, very close to maxent, will definitely maxent itself, for example, there is an odd number, so 3n plus 1 will actually fail, right? It'll be out of range. So one thing that you can cheat by saying I'll use long space, but then the problem with that is that there is no guarantee that that can be resolved in the long space. I have solved this, I've done this question. Yes, it can be done in long space. It's okay. It's not an issue. It works. But like again, the same thing. What if I were to say, fine, resolve it for all 64-bit integers, and you run this, can you actually go to like long or 128-bit integers, and will it be resolved? I don't know. There is no guarantee that you can't just simply increase the width of the integer and make this work. So anyway, it's a good question. I think it's just the idea here is just to take like a leaf from different types of questions and whatnot. Whenever you see one question, just see if there are other questions which are there as well. So we've got 2 minutes. I want to pack up and essentially just do a quick vote of thanks. Thanks, Ashish. The discussion was like phenomenal. I think this is great. Thank you for coming prepared, and I think most folks here have seen the questions, which is actually great. Made for very interesting discussions. The next set of questions will be posted in about 15 minutes. I tried to move the, I said 10 o'clock, but I want to post it at 9:45 PST. So that way it automatically goes. I just changed the schedule. So just wait up for 15 minutes. You have about 24 hours to solve those questions, or 22 hours and 45 minutes to solve the questions. And then we'll see you guys tomorrow here at 8:30 in the morning. Any questions or follow-ups?
Could we just increase the number of questions to 5?
Unfortunately, I cannot. This is all preset. For the next 2 weeks, I'm not going to change anything. So what I would recommend is, as you're discussing the questions, discuss variants of the questions and discuss complexifiers. So just like how today we talked about Collatz sequence on top of race car, there are like different ways of looking at it. Try to solve the same question in different ways and different approaches. Just by adding
really helped.
So hi Vivek, can you just also share some more resources on how these kind of problems, like the last problem that we discussed, some more problems of similar kind, and some resources that could help in exploring this kind of dynamic programming problems, like
the journey is actually half the thing here. So you will have to go around looking for these resources and go for it. Handing these resources to you as is actually won't help you a whole lot. So my feedback to you would be to take these pointers from these discussions and then go and build your concepts. I think the best place that I actually start with is for any of these questions, I actually look at the discussions in lead code, and invariably they have different approaches that they talk about. Like for example, the BFS and the DP approaches are both discussed in the discussions multiple times by multiple people. So you can just sort by popular or sort by I think most voted, and then you can start looking at the top 3 or 4 solutions, and you will see the different approaches. And once you have an approach, you can start applying your approach to it. So one of the reasons why we're picking lead code is because it actually has all of these things available. It's just much easier, and it's a well existing resource, right? So why not just use that?
Yes, right. Thank you.
All right, awesome. So that actually ends this conversation. So thank you so much for joining and being enthusiastic participants like that. Thank you. Thanks, Ashish.
Thank you.
Thanks, guys.